Okay, so for polynomial factoring, I do want to teach you this special case. Now, traditionally it's called difference between two squares, but what I just now realized is that it really works with anything when it's set up in a special way. Any of the, I'll just show you. Okay, so our normal trinomials that we've been working with have had an x squared plus an x plus a constant term, and the only difference has been the coefficients up front, plus 5x minus 7, it's three parts. It's got the x squared term, the x term, and the constant term, right? So there are some cases, as we saw, where we still have our x squared term, but we don't have the x term, but we do have the constant term. And examples like this, right? So our there's our we can have our x squared term as a trinomial, or we can have our x squared term without the x term and just the constant. So the way we can factor these, I mean, we can still use the normal scenario we've been working with using the quadratic equation, but if it's set up like this, we can also use our shortcut. And keep in mind, like it says right here, it's called the difference. So it only works when we're subtracting. If there's a plus, if we have our x squared term plus a constant, this is as factored as we can make it, unless you can factor out like the coefficients. But we can't do anything. This is considered prime when it's plus a constant, but if we have x squared minus a constant, then all we got to do is we're going to factor it into two binomials. And what we do is and one of them is going to be a plus and one of them is going to be a minus. And what you do is you take a square root of this first term here. The square root of x squared is going to be x, x. And what we do is we take the square root of this second term here. Just look at the coefficient, or ignore the sign. So the square root of 1 is 1. And then this is how we factor um, a polynomial with an x squared term and a constant. That's all you got to do. So it's called the difference in squares because you can just take the square root and break it up into two binomials like this. And remember, when it has the same values but different signs, we call those conjugates. So look, if we were to factor everything through, if we were to FOIL, x times x is x squared, 1 times x is x, x times negative 1 is negative x, and then negative 1 times 1 is negative 1. That would give us x squared. These cancel, minus 1. So it does equal what we're getting. So let me do a few other examples. And if you don't know how to do square roots yet, my next video is going to be on square roots. So you might want to watch that first. Well, if you're already this far in, you might as well just finish. But watch the square root, and then you can come back to this if you don't understand. So let's take a look at another one. 4x squared minus 25. So we see that it has the x squared term. It does not have an x term, but it does have a constant. So what we can do is we can break it into our conjugates, plus minus. What we can do is we can take the square root of this first right here, and the square root of this second one right here. Y'all know that the square root of 25, that's just 5 and 5. And then the square root of 4x squared is going to be 2x. And there we have it. This is how we factor this right here. All right. So if we were to multiply everything through, 4x squared plus 10x minus 25. These cancel. We're left with 4x squared minus 25. And let's take a look at one. Let's take a look at another example. All right. Let's say we have x to the power of 4 minus 1. All right. So let's break it up into our conjugates. All right. The square root of 1 is 1, so we know that part. The square root of x to the power of 4 is x squared. If you don't know that yet, like I said, I'll make my square root video. All right, so now we have two binomials, but look again, they both have the x squared term. So can we do some more factoring? Well, we can't do it here because it's a plus a constant, but we can do it here because it's minus a constant. So we can break this one down, do the same situation, break it into the conjugates. The square root of 1 is 1. The square root of x squared is x. All right, so This breaks down into these two, and then we still have this one from before, which is going to give us x squared plus 1. So we can break down this binomial into these being multiplied by each other. And lastly, let's do this one. It's on page 238, 16a 6b4 minus c squared. We can factor this into the conjugates. Plus minus, the square root of c squared is going to be c. The square root of 16a6b4 is going to be 4a3b2. Yep, that's right. 4a3b2. And if you notice, we do still have a square term plus and minus a constant. So in theory, you could break this down one more step. It just wouldn't be practical because then you can't really take the square root of c. You could, but it wouldn't add anything to what we've already simplified it to. So that's it. So when you see a difference between an x squared term or it's called difference of squares because ideally both of these will have a nice clean square root, but really you can do it with anything, but it just depends on the setting as to whether or not you want to. But anyway, keep an eye out for the square root video.